Okay.
With no further ado, it's time to move on and meet our next speaker.
Ognyan Chikov is senior blockchain developer in LimeChain with 10+ years of experience in computer science. Currently, he is team leader for different blockchain projects and also a mentor at LimeAcademy.
His favorite languages and tools are JavaScript, Hardhat, Typescript, Angular, React, Vue.js, and Etherlime, Ethereum development and deployment framework, written by himself.
These are also your favorite tools and languages?
Yes, of course, yes.
Besides work accomplishments, Ognyan is also an IoT master and has many side projects in the field of smart homes.
Today he is here to talk about decentralized apps.
Make some noise for
Ognyan Chikov!
Щях да кажа на здраве, успех исках да кажа.
Okay, guys, thank you very much for the amazing intro. First of all, I would like to thank to the organizers for the chance to be part of this lovely conference. And then I would like to thank to all of you that you're here and we can discuss the topic that I've prepared for today, the process of creating decentralized applications. Okay, before we deep dive into the process, let's first of all understand what is the difference between a dApp and an app. So we use traditional apps every day, whether to write an email through our desktop browser interface or to check if it's raining through our mobile devices. Such applications have one thing in common. They rely on working with centralized servers in order to sync data. And if you see the slides, here we've got two pictures. Apart from the fact that the first one is a screenshot from a desktop application and the second one is a screenshot from a mobile one, can you spot the differences between those two apps? I know, it's difficult. It's difficult to be done by those two pictures, and if you want to be more precise, it's difficult to be done by UX, UI, or design. And if you start to play with two of them, you will notice the architecture differences, but right now it's really difficult, and I'm going to explain you why in a while. So decentralized applications, on the contrary, run on peer-to-peer networks called blockchains without central servers. Their working rely on the consensus among blockchain participants, and they do not need a central authority. Some tech pundits argue that the dApps are driving the Web3 revolution that seeks to remove the centralized architecture with distributed, decentralized blockchain approach. And you may come across this truism, or you may heard it, that if you're using some application and you're not paying for it, then you're the product. And that's true. Well, dApps strive to return the power to the user by removing intermediaries and establishing a new trust-shared mechanism thanks to the cryptography. Well, what's about dApps versus apps is that they quite often look the same on the surface to the users. The only giveaway is that dApps have some kind of crypto token and economical model built in. And this economical model is frequently called tokenomics. But then again, we've got a lot of applications that are dealing with crypto tokens, for example, Coinbase, that they still rely on working with centralized servers, private centralized servers. So you can never tell whether you're dealing with a dApp or an ordinary app just solely on its look, because they may look identical. However, experienced users may interact with dApps even without graphical interface. And when we are talking about dApps or dealing without dApps, the backend stuff really matters here. We are going to discuss what's so interesting about this backend stuff, but first of all, let's see what's going on into the dApp market today. You can see two pictures. I'm going to explain them in a while, but just I want to remind you first that the peer-to-peer technology is not an entirely new concept. It's been around us, let's say, since 2005, 2006, and you probably downloaded a couple of movies through services like BitTorrent. What's important and interesting today with the modern blockchain protocols and why they stand out is the new shared trust mechanism that is cryptographically secured. And this secure, together with the immune nature of the distributed ledger technology, makes them unique, gives them all the core functionalities of the distributed ledger technologies, and make them really powerful. You can see here, it's a little bit small, but I'm going to explain to you. Those are the new dApps by month for the last few years. And according to the dApp radar, there is currently operating near more than 4,000 dApps over 25 different blockchain networks. If you go deep dive into the dApp world, you will notice one thing. Most of them are circulating around finances and games. And you will ask why. It's normally because if those decentralized applications have actions into them, and every action is a transaction on the blockchain, but you know that the blockchain is breeding with transactions, and the transactions are the core functionalities of the blockchain, it's not a new thing that they are dominating the market. And another picture here, again, shows that everything that goes around some kind of digital asset has a lot of users, and at the same time, on the right side, there are dApps that are doing healthcare, for example, or charity, and they don't have nothing to show. Because, for example, if you want to do healthcare, you need to do a patient data management. Doing that on a distributed, decentralized technology meets a lot of regulations. And yeah, companies are still strive, and it is hard to be done. I can say for now that there is a lot of momentum going on to the market, which gives the pioneers a lot of opportunities. And if you want to talk about the pros and cons of dApps, years ago when I started to do dApps, I was thinking, come on, we've got literally everything and literally app for everything in our lives. Why do we need to move to dApps or decentralized applications? There should be something that they give to us in order to switch to them. And yeah, there is. The first thing, and the most important for me, is the fact that there is no central authority. And I'm going to give you a fast example. In 2018, I believe, the Turkish government banned Wikipedia. But thanks to the decentralization and solutions like distributed shared storage on the blockchain, the Turkish users or community was able to upload the Wikipedia on such a solution, and the Turkish government can no longer ban the Wikipedia. So what does it mean, no central authority? It means that you can directly transfer transactions between the users without third party. You need to pay only for the gas fees that this transaction will consume. Impressive uptime. As you may heard, the blockchain is run or it's operating on different consensus algorithms. The consensus algorithm specifies the functions of the certain blockchain network. Nodes that are supporting this network have incentive to be always online because they make money, or they get those transaction fees that the users are paying for the transactions. Then a lot of the users, or all of them, have the ability to take part into the decentralized economy. They do some stuff and get crypto tokens for that, and later they can exchange those tokens for fiat money. The fiat money are the real money that you use every day. Security and data integrity. It's really hard to hack the blockchain network itself. I'm not talking about the dApps now on the blockchain because we know a lot of known hacks, but it's really hard to hack the network itself, because if we are stick to some kind of consensus algorithm, for example, proof of work, if you heard about it, or the Ethereum network is still working on proof of work, you need to get more than 51% of the power of the network. And with other words, right now it means that you need to have powers like China and half of the Europe in order to hack the network. It's almost impossible. Technically, it's possible, but it's almost impossible. The privacy and transparency. What blockchain gives to us is the privacy. Still, every transaction on the blockchain is free to be read, but this transaction is private because you don't know what and who is behind the transaction. You only see an address. And again, the transparency, as I said, it's free to be read, but still it's anonymous. Okay. So there is a mistake. Those are the disadvantages. There is a mistake in the presentation, sorry about that. So the maintenance. It's really difficult to maintain a dApp. Why? Because of the nature of the blockchain, or this backend stuff that I was talking about, this backend stuff is the smart contracts. And thanks to the immutability that you can see over there, it's also a feature, but it's also, let's say, a disadvantage. When you upload your business logic or your smart contract to the blockchain, it's really difficult to be updated. Nowadays, there are a lot of patterns, and we, at the company I present, we've got a book about the patterns and how you can update your smart contracts, but it's really difficult because actually you cannot update the state, you can only update the implementation of the program. And you need to be really experienced to know what you're doing. So the maintenance is really difficult. The scalability. If we get some kind of marketplace that you sell something and you want to get the Black Friday users, it's easy, you double the servers. In the blockchain, it's not so easy because you're limited with the specifications of the networks. And again, another quick example, CryptoKitties, a really nice dApp that you can purchase a crypto Tamagotchi, a kitty from it. When it was at this hype, a lot of users almost hold the whole Ethereum blockchain. The transactions become really expensive and really slow. User-friendly interface. A lot of the dApps are written by, let's say, developers that don't know anything about the UX and UI. And according to me, this is the most important stuff if we are talking about the blockchain adoption in our lives. You will see something like hashes, signatures, transaction addresses, receipts, a lot of stuff that doesn't mean nothing for the ordinary user. The slow speed. If you get Ethereum, the Ethereum can process at its best, let's say like up to 50 or 60 transactions per second. Really slow. If we get the Visa card payment provider, Visa can process 25,000 transactions per second. And if you are using Ethereum or the market that you are going after work to purchase some goods is using Ethereum, you will spend almost 6 to 10 minutes on the cashier desk to wait for your transaction to be validated, which is not sustainable. Nowadays, there are different solutions that can help and speed that. And now, okay, I talked about the immutability. Now the process of creating a dApp. On the left side is a centralized solution, and we are aiming to move to the right side and how a decentralized app may look like. You can see that on the left side there is a central point of failure, and to the right side this is a decentralized distributed app. Okay, how ordinary architecture of app may look like. We've got a user, we've got a browser, we've got at the front end hosting into the web server, and I'm expecting that you will ask then, is this web server, and where is this web server, and is it decentralized? And then we've got this backend stuff, and right now it's showed that it uses smart contracts on Ethereum. It can be literally any blockchain network that is supporting smart contracts. First of all, we need to define the purpose. Who will use your dApp and what is its incentive for using it? You can create a decentralized application when you need to create economically fair environment for all involved parts, or you need to avoid having a central point that is controlling your app. You strive from the transparency of all data modifications in the app, and as you know, and I mentioned, the blockchain is transparent, and everybody can read your transactions as well as your code. All the code of the dApps is public, and the community have the power to review it. And you plan to automate some kind of processes that can be simply written into algorithms. Okay, the architecture of the dApp. The most important thing is to choose the right and the appropriate blockchain network. Why? If you want to create an app like Spotify and all the users pay some kind of fee when they play a song to the artists, choosing an Ethereum will be dangerous because you may end to the fact and to the state that you want to pay a really small amount, but the transaction fee is large. So there are different blockchain networks that are supporting fast microtransactions, micropayments, and etc. Then the smart contracts. You need the architecture, the right architecture of the smart contracts, because it's not an ordinary program. There are a lot of patterns that you need to follow in order to avoid hacks. We know a lot of known hacks today, like re-entry attack, double spending, etc., etc. All the specifics that are coming thanks to the nature of the blockchain. And then backend and front-end stuff. And there is so it's not mandatory to have a backend. For example, if you're not dealing with any kind of user data or analytics, most of the dApps have front-end and they communicate with the smart contracts on the blockchain directly. And then you need to verify your idea. In the community, what is frequently done is we do a proof of concept or POC. A really small and basic features of the dApp are delivered, and a small amount of users are validating them. They're validating also your idea. Just forgot to mention that when you are on the architecture of the dApp, this architecture, as well as other specifics, are written into the, let's say, the white paper of the dApp. The white paper consists a lot of information about what's your idea, what is your tokenomics model, a lot of math, a lot of technical stuff. And then the most enjoyable part for me is the development process, and you need to choose the toolset. You're developers, here you know. We use JavaScript and TypeScript typically for the front end. Frameworks like React, Vue, even Angular are good to be used. Then Python, Go, Rust, and C++ are using for more backend stuff and more complicated and fast operations. Node.js and Solidity. Solidity is the language that the smart contracts are created on. Right now there is 0.9 version. There's still, we are aiming to drive to the first version of the language, but this language has a lot of specifics. And when you develop smart contracts, your aim for developing is to be, first of all, secure this whole solution, and then to be gas efficient, because every state transaction into the blockchain costs money. Hardhat framework, we used to have our framework for deploying, compiling smart contracts, but nowadays the community uses Hardhat. A lot of side tools that are helping your process, like in-browser app wallets like MetaMask. Of course, you need local networks to test your solution. Those are Ganashis and local nodes. Web3 or Ethers.js. Those are the two known libraries that the community uses the most, the JavaScript community. And then Express for backend framework for analytics and user operations data if you need. And Remix for fast, reliable testing. Step next, those two steps are step next, because as soon as you create your smart contracts, first of all, and the mandatory thing is to write unit tests. The aim is 100% code coverage. And after that, you're not ready. Those contracts are passed for external audit. This external audit, whether it's positive or negative, after we complete with the audit, then we can process with the deploying of the contracts to some kind of test network. And this is where the front end and all the different interfaces that are communicating with the smart contracts starts to be developed. They go in parallel, because before that you may start with the front end and all other stuff, but you work only with mocked data. And this is the steps where you connect your contract with your real dApp and start to observe and start to play with it. And then the backend part, you may need a lot of analytics, and the blockchain is slow to be read. That's why you may need different solutions like the graph, where you can get all the analytics really fast. They aggregate this information for you. And then the final test and launch. The first of all, after everything goes to prod environment, it's tested with small amount of community users. We validated that, again, everything is still sustainable, workable. We do final tests, and then we're ready to get the release announcements and launch our product. It's a long process with a lot of technologies that you need to get and you need to know. And for example, the ordinary team for developing a decentralized application is from 5 to 15 people, depends on their knowledge and the technologies that they can deliver. But the most important thing for me is testing, as it was on the previous lecture. So without testing your smart contracts, you cannot deploy them, because you are going to lose all your assets that they will eventually hold. And now it's time for questions.